Here we have some cutout puzzle pieces that show the common valencies for the different elements you might encounter in organic chemistry. Hydrogen always has a valency of 1, is connected to one thing. Carbon has a valency of 4. There are different arrangements that you could have 4 total bonds to a carbon atom. Nitrogen has 3 total bonds. Oxygen has 2 total bonds. And halogens, including hydrogen, all have 1 valency or 1 bond to them. So in the periodic table, it's C, N, O, and then the halogens. So that's 4 bonds, 3 bonds, 2 bonds, 1 bond. I'm going to use these puzzle pieces to construct some Lewis structures. Here in Klein's textbook, we have question 1. And I'll work through these here. So for part A, we have CH4O. So I'm going to go ahead and grab 1 carbon, 4 hydrogens, and not knowing any better, I'm going to guess that I should choose just the normal oxygen up here. And so, we can connect these in different ways, however we want. Okay. And so that would be a valid Lewis structure. Hydrogen bonded to oxygen, bonded to carbon, and then 3 hydrogens coming off of that. So that would be possible. Let's work on this next one, CH3Cl. So we need 1 carbon, 3 hydrogens, and a chlorine. By having these bonds already drawn here, it keeps us honest and not violates the octet or anything like this. So carbon's generally in the middle, so we'll start with that. We want to place a chlorine atom. Let's just go ahead and do that. And then we have 3 hydrogens and 3 little lines left, so we can just put these 3 hydrogens on the carbon. Okay, so we have a carbon in the middle bonded to hydrogen, 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 and then chlorine. The next problem is C2H6. So we need 2 carbons. I'll try to use these carbons. If there's a problem, I'll explain why we might go to a different type of carbon. 6 total hydrogens, so that's a lot. Okay, there we go. So I've got all my working materials here, 2 carbon atoms and 6 hydrogen atoms. And you see, I can't put the hydrogen in the middle of a carbon because a hydrogen can only bond to one thing. So the 2 carbons need to be bonded. And let me just try to put all the hydrogens around there and see if I have any missing or any left over. Okay, that worked out. So I've got a carbon surrounded by 3 hydrogens, bonded to another carbon that's surrounded by 3 hydrogens. So that would be a valid Lewis structure for, C2H6. This next one has a nitrogen, CH5N. So let's grab our carbon. Let's grab 5 hydrogens here. 1, 2, 3, 4, 5. Oops. Okay. And we need a nitrogen. Okay. So here nitrogen is normally bonded to 3 total things, and carbon is bonded to a total of 4. So if I try to do this, I'm stuck because I have no extra bonds left over. That's ammonia there. So I need to make that connected to a carbon. And then we'll go ahead and put these hydrogens around the remaining valencies. So carbon's bonded to 4 things, nitrogen's bonded to 4 things. So that would be a valid Lewis structure. It doesn't matter if you ended up doing it like that or like that. It's the same molecule. Our next one involves a halogen, C2H5Br. Okay, so let me get all those pieces ready. We need 2 carbons, 5 hydrogens, 2, 3, 4, 5, and a bromine atom. So bromine is a halogen, and it has 1 valency, or 1 bond that it can make to something. And so C2H5Br, let's put the 2 carbons together, and then let's just snap on the bromine there. It doesn't matter where I put this bromine. I could put it on this side. It would appear upside down, but that would be the identical molecule as what I'm doing here. So let me go ahead and connect the hydrogens up. And that's a solution there. So we've got carbon with 4 total bonds to it, this carbon with 4 total bonds to it, and we've got our bromine with 1 bond. Okay. Let's do C3H8. Okay, so I need 3 total carbons, and I need 8 hydrogens. So there's 1, 2, 3, 4, 5, 6, 7, 8. It's very easy to miscount if you're doing this with paper and pencil here. It keeps us very honest with what we need to do. So I have 3 carbons. Generally, you put all the carbons together. It doesn't matter if you bend it down, but I'll have a problem here, you see. So I just need to make them in a row there so I can fit all my puzzle pieces in. And then I'll put a hydrogen on each of the remaining lines available. Okay, so we got 3 carbons and 8 total hydrogens, so that's the correct count. Carbon has each of its bonds used up, there's none left over, and hydrogen has all of its 1 bonds used up to make this compound. So if you're really struggling with Lewis structures, I suggest cutting out these puzzle pieces. I'll provide a link in this video to the PDF where you can print this out and cut it with scissors and create all these pieces, and this will help you complete many of the problems in the initial part of Klein and get very familiar with what the common valencies are. Thanks for watching.